Welcome to lecture video on Analog and Digital Electronics Laboratory. In this video, I'll demonstrate how to simulate VHDL code for 8:1 multiplexer using ModelSim and EDA Playground. First, let us simulate 8:1 multiplexer using ModelSim. Open the ModelSim, create new project, go to File, New, Project, give the project name as EXP5. OK. Now we'll add a VHDL file to the current project. Click on create new file. Let us name the file as mux821 and file type is VHDL. OK. Now go to the project window. Click on the file mux821.vhd. Right click, edit. Now we'll write the code in the window. Before writing the VHDL code for 8:1 multiplexer, let us recall what is 8:1 multiplexer. A 8:1 multiplexer has 8 data input, that is D0, D1, D2, D3, D4, D5, D6 and D7, and 3 selector input S0, S1 and S2. Based on the value of S0, S1, S2, data input among D0 to D7 is selected at the output Y. So this is the truth table. If the selector input is 0, that is 0, 0, 0, D0 is selected. If the selector input is 001, D1 is selected. If the selector input is 010, D2 is selected. If the selector input is 011, D3 is selected. If the selector input is 100, D4 is selected. If the selector input is 101, D5 is selected. If the selector is 110, D6 is selected. If the selector is 111, then D7 is selected. So this is the code for 8:1 multiplexer in VHDL. Double hyphen indicates the comment. Entity is the keyword. Mux821 is the name of the entity. Is the keyword. Port is the keyword indicating the ports. Ports can be input port or output port. By looking into the block diagram of 8:1 multiplexer, it has 3 selector input. We'll declare the selector input as a bit vector, which is similar to array in C. So the size of the bit vector is 3, that is the index 0, index 1 and index 2. Then the data input is represented by D, and again it is a input port, and data type is bit vector, which is similar to an array. So D can be considered as an array of 8 bits. So 7 down to 0 indicate that the index of D is from 0 to 7. Then Y is the output port and data type is bit. End of the entity mux821. Now we are writing the architecture for mux821 entity. Architecture equation is the name of the architecture of mux821 is begin indicates the beginning of the block. Now we will use select type of statement. Select is similar to switch in C. With this a keyword. With yes. Yes is the selector input. Based on the selector input value, you are going to select the one of the data input as the output. Select is the keyword. Now y is the output. So y is less than or equal to, it is an assignment operator in VHDL, D0. So when selector input is 0, 0, 0, then D0 will be selected. Similarly, when selector input is 001, D1 is selected. When the selector input is 010, D2 is selected. When the selector input is 011, D3 is selected. When the selector input is 100, D4 is selected. When the selector input is 101, D5 is selected. When the selector input is 110, D6 is selected. When the selector input is D7, the that is when selector input is 7, that is 111, T7 is selected. Now end of the architecture represented by end equation. Now let us save the program. Go to project window, keep the cursor on the file name, that is mux821.vsd, right click, go to compile option, compile selected. So in the transcript window you can see the message compile of mux821.vsd was successful. If any errors are there in your code, will be shown in the transcript window. Then correct the errors and recompile until compilation becomes successful. Now go to library in order to simulate the waveform. We know that our project is saved in the work library. To expand the work library, then go to mux821, keep the cursor on mux821 file, right click and select simulate. Now simulation instance is created. In the simulation instance, select mux821, right click, select add wave and click on add wave. Now the waveform is added to the wave window. You can see the waveform. So see here, you have two inputs. One is S and second one is D. S is a array of 3 bit or bit vector. So S0, S1 and S2, based on S0, S1, S2 value, one of the D value, that is D0 to D7 is selected. Again D is an array of 8 bit, that is D0, D1, D2, D3, D4, D5, D6, D7, and Y is the output. Now keep the cursor on the S and set the input, as well as you have to set the input D. Before setting the input, let us look into the truth table. See, in the truth table, for the selector input 000, D0 is selected. That is, if the selector input is 000, if the D0 value is 1, then the output Y is set to 1. Now we'll set the selector input to 000. So S2 is set to 0, S1 is set to 0, S0 is also set to 0. When S is equal to 000, D0 is selected. So we'll set D0 to 1. Okay. Now we'll run the simulation. See here, when the input is 000, whatever value in D0 is 1 now, output Y is also 1. Now second entry in the truth table is 001 for S. So we'll set S0 to 1, S1 to 0 and S2 to 0, and we'll set D1 to 1. So we'll set D1 to 1 and we will set D0 to 0. Okay, now we'll run the waveform. See here, for the input 001, D1 is selected, D1 value is 1, so the output also 1. Now next entry in the truth table is 010, so we'll change D0 to, not D0, S0 to 0, S1 to 1. Okay, and we'll set D2 to 0, D2 to 0 to 1 and D1 to 0. Click OK and run the waveform. See here, when S is 010, D2 is selected, D2 is 1, so the output is 1. Now let us look into the truth table. When S is 011, D3 is selected, D3 is 1, so the output is 1. When the entry for S is 100, D4 is selected, D4 is 1, so the output is 1. Now let us set S1 and S0 to 1. So S0 is set to 1, S1 will set to 1, click OK, S2 is set to 0. Now we'll set D3 to 1 and we'll set D2 to 0 and all remaining D1, D0, D4, D5, D6, D7 is set to 0. Run the waveform. At the waveform you can see that 0, 1, 1. So 0, 1, 1, output is 1 since D3 is 1. Now we'll set S2 to 1 and we'll set S1 and S0 to 0. Now we'll set D4 to 1 and all the remaining D0, D1, D2, D3, D5, D6, D7 will set it to 0. Now let us run the waveform. Now we can see that 0, that is S is 100, D4 is 1, at the output Y is 1. Next entry in the truth table is 101 for S and D5 is set to 1. So we'll set S2 to 1, S1 to 0 and S0 to 1 and we'll set D5 to 1. Now we have set S2 to 1, S1 to 0 and S0 to 1 and we have set D5 to 1 and all the remaining D0, D1, D2, D3, D4, D6 and D7 to 0. Now we'll run the waveform. Here I can see that for 101, D5 is 1, at the output y is 1. Next entry in the truth table is 110 for S and D6 is set to 1 and remaining entry D0, D1, D2, D3, D4, D5, D7 is set to 0. Now let us run the waveform. Here I can see that for the input 110, D6 is 1 and the output Y is 1. Last entry in the truth table is S is 111, D7 is set to 1. All the remaining D0, D1, D2, D3, D4, D5, D6 is set to 0. Now we'll run the waveform. So we can see that S is set to 111 and D7 is set to 1. Now output Y is set to 1. Hence we have verified the truth table using the waveform by simulating the VHDL code for 8:1 multiplexer using ModelSim. Now we'll run the code in EDA Playground. So write the 8:1 multiplexer design code in design.vhd window and we'll write the test bench waveform in the testbench.vhd. So I've already written the code. Create a test bench entity. It is an empty entity. Create the architecture for test bench. Create the component. Component is same as 8:1 multiplexer code port declaration. So same, see here, port SDY you have to define like defined in the entity. Next, same port has to be declared as a signal. Then you have to map the port using that function DUT multiplexer MUX 8 to 1 port map S to S, D to D, Y to Y. Then we'll create a process for initializing. So begin. So S is initially set to 0 and D0 is set to 1. Again S is set to 001, D1 is set to 1, that is in the position 2 we are setting 1 for D. Similarly in the next entry in the truth table for S is 0, 1, 0. So we have set S is equal to 0, 1, 0 and D is equal to 1 in the second position, that is in D2 is set to 1. So next entry S is set to 0, 11 and D3 is set to 1, that is in the third position you are going to set 1. S is set to 1, 0 and D is set to, that is D4 is set to 1, that is in the fifth location you are setting 1. Then S is set to 1, 0, 1 and D is in the position 6, that is D6 is set to 1, D5 is set to 1. Again S is set to 110, D6 is set to 1. S is set to 110 and D7 has to be set to 1. Then close the process and close the test bench using end function. Next, save the code. Then in the left language and library window, select test bench plus design as VHDL. Then write the top entity as test bench. Then select the simulation tool as Aldec Rivera Pro 2020.04. Compile option -2008. Then set the runtime to 10,000 picosecond and select open EP wave after run. Then run the code. Then you can see the error message or successful of compilation. You can see it in the log window and EP waveform is generated. This is the waveform generated for 8:1 multiplexer in the EDA Playground platform. The generated waveform is correct with respect to the truth table. If you want, you can verify. Now let us see the general format of writing the test bench. So first we write a entity called test bench. Then we'll write the architecture for the test bench. Then we write the component, that is the component is nothing but the port declaration which is done in the entity of the design part. Same code I have copied. Then you declare the same input and output port as signals. Next is you have to map the port and the signal which we have declared earlier. Then within the process we write the initialization of values, that is we are going to set the input value for the circuit. So in this lecture video I have discussed how to implement 8:1 multiplexer using ModelSim simulator and EDA Playground. Thank you for watching.